To start this drawing, we are going to begin by sketching our solid to create the front view with a thickness of 50 millimeters and a diameter of 135 millimeters. So let's get going on CATIA. So we're going to start mechanical design, part design. We create our new part. I go ahead and before I get going, I reset my toolbars to make sure that they are organized for my new work. And we rename our part to an appropriate name. First, we're going to create the solid. In that case, I am going to choose my YZ plane. I'm going to Sketcher, and I create the main circumference of the object. In this case, it is 135 millimeters in diameter, which we can then pad to 50 millimeters. Now this object has a shell thickness of 2.5 millimeters. That means I can use the shell command. I can assign a thickness of 2.5 and remove the front face because I no longer need it. Now to begin, we have three sets of hole patterns at fixed diameters, 30 millimeters apart, or 30 millimeters in diameter difference between each of them, and there are 10 holes in each pattern. So for first, what we need then is the hole to begin with that we can pattern. I'm going to place a hole on the surface. It is 10 millimeters. I make sure the hole is a through hole as is indicated in the sketches. I go to my positioning sketch and I create my first diameter. In this case, this is the 50 millimeter diameter. Now I want to make sure that this diameter is at the center, so you'll notice that it is fully green and constrained. If you create a circle that is not at the center and needs to be constrained, make sure that you use a concentricity constraint. So we make it 50 millimeters and we have the main diameter. I will also like to have the hole right at the vertical location, similar to my sketch here, right above it. So I'm going to create a line that goes from the center to the edge. I make sure they coincide, and then I'm able to constrain the center of the hole to the point created by the coincidence between the vertical line and the circle. Once I have that, I have a fully constrained hole center. You can see everything is green. I can exit. I can click OK. Then I can use the pattern. The pattern comes from the transformation features toolbar. It's a little bit hidden. You may have to drag some of the toolbars out. It contains things like rotation, mirror, rectangular pattern, and in this case, circular pattern. If you have pre-selected the hole, you'll notice that the object to pattern is the hole. If by any chance you click somewhere else and you click the circular pattern, it's not a big deal. Just make sure that the object to pattern is selected to be the hole. So you want to click in this box and you're going to click the hole until object to pattern says the hole. The reference direction should be any curvature that has the same axis, and then you have the choice of how many holes there should be. So in this case there are 10 around the whole axis. There are two ways of writing them in. One, you can input the angle and you can have CATIA calculate it for you. This is 360 degrees divided by 10. Or you can have the complete crown, which always would make the whole pattern even all the way around. So we can click preview and take a look at what we have. So before we move on though, we are going to take a look at our sketch after our drawing. And we notice that there is a 10 hole pattern going around each of the other diameters. Now each of the diameters is 30 millimeters difference, which means radially there is only there's only 15 millimeters between each of these patterns. So for that, what we're going to use is something slightly different. Instead of just focusing on the actual reference, we're going to be focusing on the crown definition. Crown definition is just another pattern. Instead of patterning the hole around the center, it's now can pattern it going inward or outward. In my case, I'm going to choose 3 sets of circles. So it's going to replicate the original pattern 3 times, and I'm going to have my circular spacing. Now be careful here. This is not the diameter difference, but rather the literal difference between each of the patterns, which in my case would be a radial difference of 15 millimeters. Once you define that, you will have the circular pattern around the center and the pattern that extends outward. Just click OK, and you would have done a circular pattern for the holes on the main face of the object. The second aspect that we need to do is have the rectangular cutout on the side. For that, we need to make sure that we create a offset plane that lets us put a rectangular pocket there. So for that, I am going to drag another toolbar out, and in this case, we're going to have a reference element toolbar where we can create points, lines, and planes in space. So the first thing I want is a point in space that is at the center of my circle. And for that, I click creating a point, choose circle, sphere, or ellipse center. I select a circle. Notice that I don't select the surface, but rather just the edge. So be careful not to choose the whole surface, as everything is in orange, just the edge of the circle. And that creates the center that you want. The next thing I want is to define a plane, and I want to be careful here. I want to make sure that I see the rectangular cutout from the right side. So in this case, what I'm going to do is I'm going to select a plane, but instead of creating an offset from plane, I'm going to select parallel through point, where my reference would be the vertical plane that I'm interested in, which in my case would be the z-axis, but I want it to go through the center of the object. That way the rectangle is exactly the location that I want. I click OK, and now I have a plane right in the middle of the object. I click on that plane and I go to Sketcher. Now at Sketcher now I can draw exactly the rectangle that I want, or rather in my case, the square, the 10 by 10 square that is 5 millimeters from the back end of the part, and it is 5 millimeters from the center of the object. So I'm just going to draw my rectangle or my square. Doesn't matter, I haven't constrained it, but constraining it will get it in the shape I want. So this should be at 5 millimeters from the center axis. I'm going to double click here to keep the constraints going. This is our rectangle. This is our square of 10 millimeters by 10 millimeters. So this is 10 millimeters by 10 millimeters. And we can't forget that this is at a certain distance from the bottom of the part. We see here that that distance is 5 millimeters. So we do 5 millimeters here. Now I have a fully constrained rectangle that I can use to make a cutout. Once you exit, you go ahead and pocket it. And if you want to make sure it pockets to the right side that you want, you click reverse direction and you go up to next. Click OK, and now I have the square cutout. The next thing I want is again to apply the circular pattern. Notice that this has 20 holes around the axis. It is replicated 3 more times, as we can see from this dimension above it, but 20 holes is the number of holes that go around the axis. So again, I can choose the hole, or rather the pocket, select my circular pattern once more, and you notice that now I want an instance of 20. The angle, again, I'm just going to complete the crown. The reference elements would be any curvature that has the same axis. But we have to be careful because CATIA does remember a previous crown definition pattern, in which case I want only one set of circles. I don't want it to extend outward. In this case, it would extend beyond what I want. So I want to make sure that it's only one. And then I click OK. Now there are 20 holes around the main axis. The next thing I need to do is to extend these 2 more times. You'll notice here that I have 3 sets of the 10 millimeter rectangles, spaced at 5 millimeters apart, effectively 15 millimeters from the start of one rectangle to the start of the next rectangle, or rather the squares. I keep saying rectangles, but. So what I'm going to do is I'm going to choose a rectangular pattern. And this is going to get interesting because instead of using just a rectangular pattern on a square cutout, my reference element would need to be my main axis. But you can use the curvature that you want. The next thing that you need to select, though, is not going to be the current solid, but rather the circular pattern that you established at first. So now we're applying a rectangular pattern to a circular pattern. Patterns can be applied pretty much to almost any element on CATIA. So in this case, we're simply applying it to a circular pattern. We want 3 instances of it, as we always choose the total number of instances that should appear. And the spacing should be the total spacing, not necessarily the gap between the squares, but rather the spacing from the beginning of one square to the beginning of the next, which in my case would be 15. Once I do that, I'll click OK. And I will have replicated the part.